Engineers don't always design structures to be as strong as possible. Sometimes they design them to fail. That might sound like bad engineering, but in reality it's often what prevents disasters. Most people believe that the safest structure is the strongest one, something rigid, something that never breaks. But in engineering, strength alone can be dangerous. When energy has nowhere to go, it destroys everything. This is why many systems are designed for controlled failure. The idea is simple. If something must break, decide what breaks first. A small, predictable failure is far better than a sudden collapse. Electrical fuses are designed to fail. When current becomes too high, the fuse melts. That single failure protects the entire system. Without it, cables overheat, equipment burns, and fires start. Modern cars are not designed to stay rigid in crashes. They are designed to deform. Crumple zones absorb kinetic energy by collapsing. The car takes the damage, so the human body doesn't have to. A car that never deforms would transfer all force to the passengers. In earthquake zones, buildings are designed to move. They bend, crack, and dissipate energy. A perfectly rigid building resists motion until it suddenly fails. A flexible one survives by sacrificing parts of itself. Some bridges contain sacrificial components. These parts are designed to fail first during extreme events. Replacing a damaged component is cheaper and safer than repairing a collapsed bridge. Dams are not designed to block all water forever. They include spillways, controlled overflow paths. Letting water escape in a controlled way prevents uncontrolled destruction. When the public sees cracks, deformation, or damage, they assume something went wrong. Often, the opposite is true. The system is behaving exactly as designed. Airplanes have parts designed to fail safely under extreme stress. Wings or stabilizers are built strong, but in certain extreme conditions they can deform or even break in a controlled way. This protects the rest of the plane and gives pilots time to react or make an emergency landing. In chemical plants, safety valves are a classic example. If pressure in a reactor gets too high, the valve gives way, releasing a small amount of substance. It's far safer to release a little than to risk an explosion that destroys the entire plant. Digital systems also use controlled failures. When servers are overloaded, some requests are rejected to prevent a total crash. Think of it like a fuse or a crumple zone, but in software form. Nature often survives through controlled failure. Trees bend instead of snapping during storms. Bones have zones that fracture under extreme stress, protecting vital organs. Engineers often copy these solutions from nature, designing safety through bending, cracking, and controlled failure. Problems appear when cost-cutting removes safety margins, or when maintenance is ignored. Designed failure only works if the system is understood and respected. Good engineering isn't about preventing failure at all costs. It's about choosing how something fails. Because the safest systems aren't the strongest, they're the smartest.